Astronomers spot first stars billions of years after they were supposed to die. Over the course of billions of years, the universe has steadily been evolving. Thanks to the expansion of the universe, we are able to see back in time to watch that evolution almost from the beginning. But every once in a while we see something that doesn't fit into our current understanding of how the universe should operate. That's the case for a galaxy described in a new paper published in the Astrophysical Journal Letters by PhD student Sidya K. of Tsinghua University's Department of Astronomy and their colleagues. They found a galaxy formed around 11 billion years ago that appears to be metal-free, indicating that it might contain a set of elusive first-generation POP-D stars. Before we get into the discovery itself, some context is necessary. Population A, POP-J, stars are considered to be the first generation of stars that formed early in the universe's history. Importantly, they have essentially no metal, which in cosmological terms means any element other than helium and hydrogen, since those heavier elements can only be formed in stars themselves or in the supernovae they create. By definition, the first generation of stars can't contain them. Cosmologists have been searching for examples of these POP-A stars for decades, but so far have been unable to find them. Typically, they search a time of the universe's history known as the epoch of reionization, which took place up to 1 billion years after the Big Bang, when the universe was very young, and we believe they first stars themselves were starting to form. So imagine the authors' surprise when they found a galaxy that appeared about 2 billion years later than the epoch of reionization. By that point, plenty of stars should have lived and died, with their remnants infecting any nearby gas and dust clouds or other stars themselves with the metal they created. That was the theory, at least. But using data gathered by the James Webb Space Telescope, JUST, the Very Large Telescope, VUCT, and the Subaru Telescope, the authors identified a galaxy they called UNC3, or C3 for short. The spectral signature of this galaxy was unique among all other galaxies of that era. It had very clean hydrogen and helium lines, and, notably, almost a complete lack of metals like oxygen in its spectral signature. In fact, the upper limit of the metallicity of the stars in the galaxy puts them at 7% of the metallicity of our Sun. Even more interestingly,